first of all, hello, my name is Johannes Teufel and I'm an innovation engineer for analytics at DXC Technology. For those of you who don't know DXC is a globally operating technology provider, and during the past months we have been working together with the startup Brytlyt on how to accelerate the use of artificial intelligence and an effective operation of AI for our clients, companies in general. DXC Technology has been involved in this topic of MLOps since quite some time already, but there are some special use cases that require special treatment and an intensified use of real-time analytics. So this is the case when companies require many specific model variations for different kind of machines, components and products. And then additionally we have the fact that data loses its value over time. So for instance, let's think back to COVID, when the consumption and production patterns of many companies changed. So the data of 2019 and earlier became completely worthless. And as a result, the AI models based on this data could no longer be used without any error or concern. And when we combine this with numerous variations in models, this can accelerate the obsolescence of data. So this becomes particularly problematic when training, testing, and deploying new models takes a long time. So we aim to address this issue together with Brytlyt. Brytlyt is capable of processing large amounts of data on the GPU at an exceptional speed, which is complementing our DXC offering regarding MLOps and manufacturing quite well. And to accomplish this, we have designed this pipeline, you can see in the back of me, for cloud-based data processing in Industry 4.0 scenarios. Technologically, we are flexible in this regard, but in this case, we are using the cloud-based scalable data warehouse provided by Snowflake to store real-time data from IoT devices. So in this case, we collect data directly at the device and stream it into the cloud, which assures availability of data for further processing. And I guess that's your part.
Right. Thanks, Johannes, for the introduction. My name is Lucas Das Dores. I am a data scientist in Brytlyt, and in Brytlyt we offer part of this pipeline here as a GPU-accelerated database and in-database AI. As Johannes mentioned, there are several challenges for implementing this kind of pipeline. This pipeline of real-time streaming and real-time analytics, and we devised a project here that's to showcase how we can actually use GPU acceleration and in-database AI. So what we devised here was to stream data from a robot arm that is going to stream the energy consumption to Snowflake, and we can stream that to Brytlyt to use the GPU acceleration and in-database analytics. Why using that? GPU acceleration really is important for real-time streaming, especially when you have several components, several pieces, several robot arms, several components of your production pipeline. You need to stream this data quickly, you need to process this data quickly on the ETL, and GPUs are very well suited for that. And why in-database AI? In-database AI throws your AI close to your data warehouse. What I mean by that is that you don't need to move the data that is being fed to the GPU to any other environment to train and deploy your machine learning model. This all is done outside our own platform. And the way we did that is doing the streaming of the data of the robot arm to Brytlyt. And one of the challenges that we're tackling and we're showing on our pilot project is data drift. What does that even mean? So when you have machine learning in production, live in real-time data, the environment tends to change. Data always changes over time. So that means that if data changes significantly from the data that you use to train your machine learning model, it's going to start outputting rubbish, essentially. So that means that you need to have a platform that can quickly react to that, and you can retrain and redeploy your model. And the way we do that, we simulate the two movements of this robot arm, and we can change between them. And we have two optimized models. So if we change the model without changing the movement, we're going to have poor performance, and the other way around as well. And we can show that directly on our booth. So you can come to our booth and see how that will work. So for what we are doing with the robot arm, this is directly energy optimization, so you can forecast and budget it more tightly if you have machine learning models which produce better forecasts of how much energy you're going to use. But you can use that with several other use cases. You can do the real-time monitoring of the rest of your systems with that. You can do anomaly detection for your production pipelines. And of course, you can do cost and revenue forecast for several of your systems. So you can find us just behind this stage. So it's in this part of the building. We're there on the back. We are happy to share with you more details and show the robot arm in action and show how we actually do the MLOps procedure in a very simple way with a few clicks. So thank you all for your attention and see you in the booth.